Like in my previous two videos, I'm going to use this structure to help explain what happens to the cupcake case after it's released, which in this case is it's going to reach terminal velocity fairly quickly. Let's start by watching the video and seeing what happens. Let's start with the moment that the cupcake case is released. So the first step is to identify the forces acting at that point. As it hasn't yet started moving, the only force that's going to be acting is going to be weight, or the force of gravity, which is going to be acting downwards. The resultant force is therefore exactly the same size as the weight and acting in the same direction, so let's draw that in. Now we need to explain the motion using the resultant force. Since it's stationary and the resultant force is down, it causes it to accelerate down. So to put that all together, when the cupcake case is first released, the only force acting is weight, which is acting down, therefore the resultant force is down, and therefore the cupcake case will accelerate down. Now let's consider things again a little moment later when the cupcake case is moving down slowly. We still have the weight force acting down, which is exactly the same size as before, but now because it is moving slowly down, we have an air resistance which is acting up. Remember that the resultant force will be the single force that would have the same overall effect as the weight acting down and the air resistance acting up. Therefore, the resultant force is still down, but is a little bit smaller than before. If I'm being good, then this difference in length of the resultant force and the weight should be equal to the air resistance size. So because the resultant force is down and it is moving down already, it will continue to accelerate downwards. But the acceleration will be at a slightly lower rate than before because the resultant force is smaller than before. But what happens as it gets faster? Well, as it gets faster, the air resistance is going to get larger. So let's now consider what happens after it's been falling for a little while. We still have the weight acting down, which will be exactly the same size as before, but now because it's going much faster, the air resistance has increased, and the air resistance is the same size as the weight, but in the opposite direction. That means that the resultant force is 0 newtons, or there is no resultant force. Therefore, we have got this scenario of 0 resultant force on an object which is already moving, which means it falls at constant velocity. So to put that all together at this stage, when it's been falling for some time, the air resistance is the same size as the weight, but in the opposite direction. Therefore, the resultant force is 0 newtons, and therefore it falls at constant velocity or terminal velocity. Hopefully you can see that you can explain all sorts of motion by just following through these three crucial steps: identify the individual forces acting and their sizes and directions, therefore explain the size and direction of the resultant force, and then use that resultant force and an existing motion to explain what happens.